Hello, everyone. It is our great honor to be here to give you a presentation. Our class is AMA1501 TUT006, and we're Group A. My name is Cao Xiaofan.
My name is Chen Mingkai.
My name is Ren Yuyang.
My name is Zhang Xiaohan.
My name is Zhu Xinyue.
My name is Zhong Yubo.
Now, let me start off with question 1.1. The following table shows the balances on a random sample of 150 customers' credit accounts. And here is the table. It asks us to calculate the mean, mode, and standard deviation of the balances. So first, let me calculate the mean. So according to the formula, x bar equals to summation xi fi over n equals to summation fi, where xi equals to the midpoint of the ith class and fi is the frequency of the ith class. We could calculate mean as 36 times 50 plus 51 times 150 plus 24 times 300 plus 27 times 500 plus 12 times 750 over 150, where 36 is the frequency of the first class and 50 is the midpoint of it. And 51 is the frequency of the second class and 150 is the midpoint of it. And 24 is the frequency of the third class and 300 is the midpoint of it. And 27 is the frequency of the fourth class and 500 is the midpoint of it. And 12 is the fifth class midpoint, is the fifth class frequency, and its midpoint is 750, which divided by n, which is the sum of the frequency, which is 150. And after the calculation, it should be 261. Now let me calculate the mode. So the mode in the group data should be calculated by L1 plus D1 over D1 plus D2 times L2 minus L1, where L1 is the lower class boundary of the model class. So here the model class should be 100 and less than 200 because the frequency of it is 51, which is the largest. And the lower class boundary of it is 100. And D1 is the difference of the frequencies of the model class with the previous class and is always positive. So the frequency of the model class is 51 and the frequency of the previous class is 36. 51 minus 36 should be 15. And D2 is the difference of the frequencies of the model class with the following class and is always positive. So still the frequency of the model class is 51 and the frequency of the following class is 24 and 51 minus 24 is 27. And L2 is the upper class boundary of the model class which is 200. And after that, we could get a calculation. Mode equals to 100 plus 15 over 15 plus 27 times 200 minus 100, which is 135.71. So the last one for question 1 is standard deviation. So the formula of the standard deviation should be root of summation f of x minus x bar square over summation f minus 1. So x bar is the mean. And after that, we could get a calculation. And which is root of 36 times 5 minus 50 minus 261 square plus 51 times 150 minus 261 square plus 24 minus times 300 minus 231 square plus 27 times 500 minus 261 square plus 12 times 750 minus 261 square, where the calculation inside the bracket is the midpoint minus the mean, and the first number of each calculation is the frequency, and after the calculation the standard deviation should be 211.73.
Let's move to question 1.2. Each person who applies for an assembly job at IDEA Furniture is given a mechanical aptitude test. One part of the test involves assembling a dresser based on the numbered instructions. A sample of length of time it took 42 persons to assemble the dresser was organized into the following frequency distribution. This question is about measures of group data. Question A. Compute the mean and the median of the length of time. The mean in group data X bar equals summation of Xi times Fi over N, where N equals to summation of Fi. The left table shows the class mark Xi. So after calculation, the mean of this group data is rounded to 7.43 to 2 decimal places. The median in the group data follows this formula. In this question, according to the accumulated frequency, the 21st and the 22nd numbers are in the group of 6 to under 8. So this group is the median class. L1 is the lower class boundary, which is 6, and L2 is the upper class boundary, which is 8. So after calculation, the median of this group data is rounded to 7.29 to 2 decimal places. Question B. Compute the range and the standard deviation of the length of time. According to the definition of range, range is the difference between two extreme values, and the range equals to the upper class boundary of the highest interval, which is 14, minus the lower class boundary of the lowest interval, which is 2. So after calculation, the range is 12. The standard deviation of group data follows this formula. The former formula is the definitional standard deviation, and the latter is the calculational one. So we choose the latter one to calculate. So after plug into this formula, S is rounded to 2.596 to 3 decimal places.
My name is Chen Mingkai. I will talk about the question 1.4. Let's first talk about the part A. From the figure, we know that it is a group data. To calculate the mean of the group data, the first step is to determine the midpoint of each class. For instance, the midpoint of the first class boundary is 100 plus 120, then divided by 2, which is 110. Then these midpoints must then be multiplied by the frequencies of the corresponding classes. The sum of the products divided by the total number of values will be the value of the mean. The mean is 161.2. To calculate the median of the group data, we should use this formula. The class in which median falls is 160 to under 180. L1 is the lower class boundary of the median class, which is 160. N is the total frequency, which is 50. C is the cumulative frequency just before the median class. From the figure, we know that it is 21. Fm is 16, which is the frequency of the median class. L2 is 180 because 180 is the upper class boundary. Therefore, by using this formula, we can calculate that the median is 165. Part B. The range is calculated as the difference between the upper class boundary of the highest interval and the lower class boundary of the lowest interval. Therefore, the range is 220 minus 100, which is 120. To calculate the standard deviation, we should determine the mean. Then we square the differences between the midpoint and the mean. Next, we times the frequency, sum them up, and then divided by m-1. M is the total frequency. Finally, we square root the results and get the standard deviation.
Hello everyone, I'm Zhang Xiaohan. Now let me introduce the solution to question 1.5. The question is the number of cars sold by each of the 10 salespeople in an automobile dealership during a particular month as follows. And we should determine the mean, standard deviation, range, and interquartile range. Next page, please. Let's move on to question A, calculate the mean. As we learned from the lecture, we know that at first we should add all the numbers in the sequence up and then use this result divided by the amount of the sequence. In this question, that is 96 divided by 10. So the mean is 9.6. Let's move on to question B, calculate the standard deviation. As we know from the question A, the mean is 9.6. As we have learned from the lecture, we know that variance equals to the square of standard deviation. So we always calculate the variance at first. The process of calculating the variance is here. We always add the square of each number minus the mean and use this result divided by the amount of the sequence minus 1. In this question, the variance equals to 17.38. So the standard deviation equals to 4.17. Next page, please. Now let's move on to question C, calculate the range. As we have learned from the lecture, we know that the range equals to maximum minus minimum. In this sequence, we know that the maximum is 15. The minimum is 2. So the range equals to 15 minus 2, that is 13. Let's move on to question D. Calculate the interquartile range. As we have learned from the lecture, we know that the interquartile range equals to Q3 minus Q1. The first quartile Q1, that is lower quartile, and it is 25 percentile. Third quartile Q3, that is upper quartile, and it is 75 percentile. When we calculate Q1, we always need to calculate I. I equals to 25% multiply the amount of this sequence. In this question, that is 10. So we got I equals to 2.5. And we learned from the lecture that if I is not an integer, round up I to the nearest integer. We should pay attention to the words up. So the I in the process of calculating Q1, I should be 3. That means we should find the third number in this sequence. So Q1 equals to 7. Apply the same method, we can get Q3. Q3 equals to 12. So the interquartile range equals to Q3 minus Q1. That is 12 minus 7, and it is 5.
Thank you, Zhang Xiaohan. The question is 1.7 now. It is about the coefficient of variation. Following are simple survey time data from completing a test from Team A and Team B. Calculate the coefficient of variation from Team A and Team B. Next, please. First, we need to calculate the mean and standard deviation of Team A and Team B. By calculating, the mean of Team A is 13. The standard deviation of Team A is 3.92. The mean of Team B is 22.2. The standard deviation of Team B is 7.51. Next, please. In the end, because the coefficient of variation is equal to standard deviation divided by mean times 100%, so the coefficient of variation of Team A is 30.12%. The coefficient of variation of Team B is 33.83%. That's all.
Now we are going to question 1.8. And below are the mean, median, and standard deviation of marks obtained by students taking a statistics course in 3 tests. Here's the table given by the question. We got test 1 and test 2. The mean for test 1 is 28. Median for test 1 is 26, and the standard deviation for test 1 is 6. Mean for test 2 is 32, median for test 2 is 34, and the standard deviation for test 2 is 7. We are going to calculating the Pearson's second coefficient of skewness and interpret the result. The equation of Pearson's second coefficient of skewness is 3 times bracket mean minus median bracket over standard deviation. And by subbing the numbers, we can get test 1. The result of test 1 is 1, and result for test 2 is minus 6/7. And we interpret the result as for test 1 as larger than 0, so it's positively skewed, and for test 2 as is smaller than 0 and is negatively skewed. That's all for today's presentation. Thank you for listening and wish you all the best and hope everyone stays safe in Hong Kong. Thank you.